this video, we will look at addition and subtraction of fractions. The first and foremost rule of addition and subtraction of fractions is that we have common denominators, okay? Common denominators means the same denominator. So if you think of the denominator as the number of equal-sized parts that the whole is being divided into, then whenever we add or subtract fractions, we should be looking at the same equal-sized parts, okay? So in this case, when we have a common denominator of C, the common denominator remains the same, and we just add the numerators for addition. And the same goes for subtraction. We keep the common denominator as the denominator, and we perform the subtraction across the numerator. So let's take a look at some numerical examples. Notice that we have common denominator in the first one. Those are 8s, so we can keep it as the denominator for our sum, and in the numerator we should do 3 plus 2, which gives us 5/8. And in fact, if we want to take a look at, what's happening visually when we do that, I can use some shapes. Let's see. I'm just going to I'll do a square. That's a whole. I will divide it into 2 equal parts. Those are halves. I will divide it into 4 equal parts. Those are quarters. And when I divide each of those into equal parts, I now have 8s, right? So if I shade my 3/8 with blue, and I shade my 2/8 with red, I now have a total number of 3/8 plus 5/8. Sorry, I keep saying that. Plus 2/8 is a total of 5/8. All right, so we must have the same size pieces. Let's perform the same thing with a subtraction. We will keep the common denominator and do the subtraction in the numerator, and we get 3/10. Even when we have literal terms, the common denominator is given as y. And so in the numerator, I will do 9a, subtract 5. And that's as far as we can go because those are not like terms. We cannot subtract 5 from 9a. And so we will leave it like that. Now, if we do not have common denominators, we need to find a common denominator. And we can always find common denominators by actually multiplying the denominators together to find a common denominator. However, it is helpful, especially with algebraic expressions, to actually use the lowest common denominator. So here is a procedure for finding the lowest common denominator. If you use the lowest common denominator, you will not need to reduce the fraction later. So that's the benefit of finding the lowest first. If you do not use it, then there's likely you will need to reduce at the end. So finding the lowest common denominator, factor each denominator into its prime factors. And I believe we have spoken about prime factors before. So that should sound familiar. For each of the different prime factors that appears, note the highest power to which it is raised in any one of the denominators. And then for part 3, multiply all of the different prime factors, each raised to the power found in step 2. This product is the lowest common denominator. Let me show you an example of what I mean, first by using a numerical example. So we are going to factor each of the denominators into their prime factors. And I see that 6 is equal to 2 to the 1 times 3 to the 1. And 10 is equal to 2 to the 1 times 5 to the 1. And we want to note each of the prime factors to their highest power. And the product of each of these is the lowest common denominator. So the lowest common denominator is equal to 2 to the 1 times 3 to the 1 times 5 to the 1, which is actually 30. Notice that that is not 60. 60 is a common denominator, but it is not the lowest common denominator. So we will use 30 as our lowest common denominator. Let's make each of them equivalent fractions over 30. So 2/6 I want to turn into a fraction. Well, let's not have the equal sign right there just yet. To a fraction over 30. And I need to, in order to turn 6 into my 30, it is multiplied by 5. Therefore, we better do the same up here. And we get 10. So 10/30 is equal to 2/6. And my 3/10, I want to make it into a fraction over 30. And so what is 10 multiplied to get 30? It's multiplied by 3, and this should be multiplied by 3, which gives me 9. Now, this is where I can do an equals. I have my equivalent fractions, each over 30, 10 over 30, plus 9 over 30 equals 19 over 30. Let's now take a look at one that involves algebraic terms. And remember, we should factor each of the denominators into their prime factors first, all right? So let's look at the first one, 6a squared b cubed is going to be 2 to the 1 times 3 to the 1 times a squared times b cubed. And my other one, 10 ab to the 4 is equal to 2 to the 1 times 5 to the 1 times a to the 1 times b to the 4. Now remember that the lowest common denominator is equal to the product of each of these prime factors to their highest power. So we look at the 2's first. The highest power on the 2's is 1. Then we'll look at the 3. The highest power on any 3 as a factor is 3 to the 1. Then I'll look at the 5. The highest power is a 1. Then I'll look at the a's. The highest power is a 2. And then I will look at the b's, and the highest power is 4. So this lowest common denominator is actually 2 times 3 times 5, which is 30a squared b to the 4. There is our lowest common denominator. We need to write each of our fractions over 30a squared b to the 4. A squared b to the 4. So I want to think about going from, let's look at the first fraction, 6a squared b cubed. What is it multiplied by to get to 30a squared b to the 4? So we have to multiply it by 5, not by a squared because that's the same, but b. Okay, so that's getting, if I multiply this, let's look at that. 6a squared b cubed times 5b. We will get, 6 times 5 is 30. A squared b to the 4. That's what we want, right? So we should do the same thing to the numerator, 2 times 5b. And 2 times 5b will be 10b. Now take a look at this one. What does it get multiplied by? 10 times 3. So let's write it. We'll write our 10ab to the 4 times what? Well, it has to be multiplied by 3, and it's multiplied by another a, and that's it. Okay, so 10 times 3 will get us 30, a times a gets us a squared, and b to the 4. All right, so we have to multiply by 3a. 3 times 3a is 9a. And so our result is over 30a squared b to the 4, 10b minus 9a. And those are not like terms, so we cannot go any further. Now, these are fairly complex fractions involving algebraic expressions. And in order to find the lowest common denominator, it is very helpful to be able to factor each, okay? So let's take a look at each of the denominators. First, I have x squared minus 2x plus 1, and I want to factor it. Now, that's a trinomial, so I will use my methods of factoring a trinomial, where I am looking for, what are we looking for in this case? We want to have a product of 1, and we want to have a sum of -2. So the only time we can get a product of 1 is with plus 1 and plus 1, and that sum is 2. Or -1 and -1, and that sum is -2. And that's actually the one we want, the -2. So this one is going to, we will split that -2x into x squared, subtract 1x, subtract another x plus 1. And I'm actually just going to add a little bit of room below there. So that becomes, remember what we did here? We have to group them and factor. So factor out an x from here. We're left with x minus 1. There's a 1 in front. X and minus 1. And double check that. So there's a negative there. -1 times x is -1, and -1 times -1 is plus 1. Good. Remember, these two need to be the same inside the bracket. So that factors into x minus 1, x minus 1, or we could also say x minus 1 all squared, okay? Now, x squared minus 1, the next one, is actually a difference of squares, and the difference of squares factors into x plus 1, x minus 1. And the third one, x squared minus x, actually has a common factor of x, and we're left with x minus 1. So now we have them all factored, and each to their greatest power is going to be, if we take the product of each to their greatest power, it will be the lowest common denominator. So the lowest common denominator is equal to, let's see, we have x minus 1 is part of this one. Now it's to the 1 and to the 1 and to the 2. So x minus 1, the greatest power is to a 2. Okay. Another factor is x plus 1, and it's only there to the power of 1. And then we just have a lone x, so that's like that. So this is our lowest common denominator. It looks a little strange to have the x hanging on the end, so I will just rewrite it like this. And the highest power there. So that's the lowest common denominator for these much more complex fractions. Let's take a look at one last example where we will add using the lowest common denominator. And I want to find the lowest common denominator. If I take a look at the first one, 2x squared y. We have, so 2x squared y. 2 doesn't factor any lower down, so 2 times x squared times y. And xy, these ones aren't really going to split up much more. And 3xy cubed. 3 does not factor any lower, y cubed. So we look at each factor. The lowest common denominator is the product of each of those to their highest power. So 2 times 3. Now the highest power on the x's is the squared, and the highest power on the y's is y cubed. So this would be 6x squared y cubed is our lowest common denominator. I want to write each fraction over the lowest common denominator. So let's first take a look at fraction number 1. 5 over 2x squared y. We want to make it equal. Actually, we'll leave a space so we can show what we multiply by. I want to put it over 6x squared y cubed. What does it need to get multiplied by? Well, 2 should be multiplied by 3. So we've got to multiply by 3. X squared times 1 will get me x squared. And y to the 1 times y squared. So we multiply here by 3y squared as well. And we get 15y. That should have been a squared. Y squared. Close one. Almost made a mistake there. Let's take a look at the second fraction. 3 over xy. I want it to be over 6x squared y cubed. So I need to multiply by 6. And I need to multiply by an x to the 1 to get me x squared. And I need to multiply by a y squared. So 6xy squared there, which gets us 18xy squared for the numerator. For the third one, so I have 4 over 3xy cubed, and I want it to be over 6x squared y cubed. We will multiply it by 2 and by x, which gets us 8x for the numerator. Okay, so now we have them all over common denominators. We need to add each of the numerators and put them over the common denominator. So my answer, if I bring it from above, you can't see that, but that's up there, equals, and it's not equal to the line beside it, just so you know. Let's put it all over 6x squared y cubed, and we will add those numerators. We've got 15y squared plus 18xy squared, and actually subtraction, so I missed that. We should probably put that like that, so we get that there, and we get minus 8x. Now we cannot add any of those. None of them are like terms. We don't even have common factors. No. So I think we'll just have to leave it exactly like that. And so there's our answer. Thanks for watching. Bye.